In this video, I'll be discussing the oscilloscope. The oscilloscope is an instrument that is used to, amongst other things, to measure the voltage across electrical components. It could be a resistor, could be a power supply, could be a lot of other things. The oscilloscope is kind of like a multimeter, but it has a screen. And the screen shows you not only the voltage across, say, a circuit element like a resistor, it can also show you the shape of the voltage that you're measuring. So it could be a sine wave, it could be a square wave, it could be other waves as well. So the oscilloscope looks very much like a computer. It has a screen and buttons and knobs. So every oscilloscope usually comes with a multimeter, a user manual, that is. So of course, just like any other instrument, you need to go through the user manual to understand how it works. And of course, you need to know what's the limit on the voltage limit that you can connect the oscilloscope to. So here right away we can gather some information about the oscilloscope. So here it says 300 volts, so we shouldn't go over 300 volts. And at the back you will have even more information at the back of the oscilloscope. So you need to, of course, gather some information from the oscilloscope. So this is the code, Tektronix TBS1202B. This is a digital oscilloscope. And so what I will be doing right now is to show you some preliminary things about the oscilloscope. One of the things we know about a multimeter is that there are probes, there are two probes, and the oscilloscope is kind of similar. The oscilloscope here, this one right here, has what are called channels. And so it has two channels. This one has two channels. So you can display two waveforms or measure two waveforms on the same screen. You can display them both simultaneously or one at a time. That's an option that the oscilloscope provides. And unlike a multimeter, well, at least the ones that we have here, like those ones, you can't display two voltage sources at the same time. But this one can. The oscilloscope can. So the first thing that you need to do when you have an oscilloscope, of course, you need to know what its ratings are, so you don't damage it. And then notice here I have a probe. This is a passive probe. So there are active and passive probes that come with oscilloscopes. So we're just going to be dealing with passive probes. And so the first thing you need to do is connect this to the compensation terminals here. Put this here. So notice here I have what is called probe comp. So comp stands for compensation, and you need to know if this probe right here is properly compensated. So you can make some adjustments to compensate it. So I'm going to connect the probe. I'm going to connect, so notice it has an alligator clip, and this would go right here. So notice here we have a ground, and at the top I have a signal, a square wave signal. And so this is the signal that is going to be displayed on the screen. And right below probe comp, it shows you a wave. So this doesn't mean it's a sine wave. It just means approximately 5 volts at 1 kilohertz. That's what the wave is there for. So we're going to get a square wave. That's what I expect to see on the screen. So the alligator alligator clip goes there, and this thing comes here. But I still don't see anything on the screen. Well, it's not that difficult here. It's just because you actually need to press this button, yellow button. Once you press it, you will see what your probe is reading. So notice the probe here, you notice here there's a yellow band and this one has a blue band. And notice the blue and the yellow button. So they correspond, they just allow us to more easily identify which probe is reading what. And you have also here blue and, blue and yellow band. So they help you just in case these come off. So they help you identify, okay, which probe, is being displayed. So this is actually convenient, so you don't have to kind of guess. You already know from the blue display, the yellow display that is, it's channel 1 that you have. So now that I can see this wave, it doesn't exactly look like a square wave. It's kind of like a square wave, but not exactly. And the reason for that is because it is not properly compensated. So to compensate it, so you need to compensate your probe whenever you use it so that it gives you accurate measurements. So I'll use this screwdriver right here, and there is a screw here that will allow me to modify the compensation. So I'll just turn it, and you'll notice as I turn, the wave changes. Okay, so this is not what I want. I want it to be as straight as possible. I don't want any sharp edges, so I'll do my best. Some oscilloscopes do this. You just press on a button and it will compensate it automatically. But we don't have, this oscilloscope doesn't do that. So I think this is okay. This is okay for me. So there are a few things. When you're capturing a wave, you can select auto set, and it will capture it automatically for you. You don't have to do much work. You can. There's a default setup. Whenever you press on default setup, it's the factory setup that is set on the oscilloscope. Auto set is whenever you're having trouble or you don't know how to use the scope, you can press auto set and it'll help you capture a signal. So whenever when I hit auto set, I get a menu, and notice I get a couple of options here. Notice the different options. So so I have this option right here. It will just display a single pulse. I have this option here that will display the slope. And notice the slope is actually not a vertical line. So notice the rise time here. It's very, very quick. 600, and it varies 600 and something nanoseconds. So it rises very quickly. So it's a vertical straight line, but if you get closer, well, from far away it looks like a vertical straight vertical line, with a rise probably of 0, but it's actually not that. The rise is quick. The rise of the slope is quick, and it's a little over 600 nanoseconds, 600 and something nanoseconds. So the falling slope also is not a vertical straight line. It's also very quick, 600 and something nanoseconds. But there are other things that are important here. So notice here it says approximately 5 volts. So from peak to peak I should get 5 volts and 1 kilohertz. That's the frequency of the signal. So if we look down here, it says the peak to peak is 5.2, and it also shows you the period, and it shows you the mean and the frequency. But we don't need all of that. We only need the frequency, 1 kilohertz approximately. That's what's showing here. and peak to peak is 5.2. So it's not 5 volts. We're not getting exactly 5 volts, but that's what it's saying here. It's saying approximately 5 volts and not 5 volts. So there are a couple more things here about the oscilloscope. So I want to touch on how to capture a signal. So there's something that is called a trigger, and the trigger is there to actually capture a signal. And the trigger has to be properly positioned to synchronize with the signal, the incoming signal, in order to trigger it. So the trigger actually, so I'm just going to press on this. This is an on-off button for the menu. So the trigger, you can notice here, I have an arrow here. So what I'm going to do with that arrow, I'm going to bring it down. Okay, I'm going to bring it down with, see I have a trigger menu here. So with the level knob, I'm going to bring it down. So notice what happens when I bring it down. So notice there's a line that displays. I bring it down. See, let's see what happens. So the wave starts to move. I'll just keep going down here just to show you what happens. So now if you look, now it's showing me, well, your line there is way below the screen, and so it helps me locate the line, the trigger line. So I'm going to do, so notice now the wave is moving. So it's not a stable wave. So I'm going to bring back my line and cut the wave. Immediately it's stabilized. So I'm just going to keep going up. So as soon as I no longer cut the wave, it's now unstable. The wave is unstable. It's moving. So I'm just going to keep going up. Notice now it's showing me that the line is beyond the screen. So I'm going to bring it down again and show you that. So now it's stabilized. So there's another trigger, horizontal trigger point or arrow. It says T right there. And what I'm going to do with it, I'm going to reposition it. So it's right now in the center, and that's where I like to have it. Of course, you can change its position. And what I'm going to do is I'm going to change its horizontal position right there with this knob right there. Okay, and I'm going to look how it's moving my wave, moving it to the left. And so now it's showing me that the trigger is beyond the screen. I'm going to bring it back. I'm going to move it. Notice the wave moves along with this arrow. And notice this is the maximum. I can't go further. Okay, I like to put it in the middle, at least for this experiment. The other thing that I would like to show you is there's a trigger menu here. If I press on the menu, it shows me the trigger menu, and you can display a lot of things. You can the type edge. So of course you can change that. You get a drop-down menu. The source is channel 1, so that's from where you're getting your signal. That's this probe right here is from channel 1. It's not from channel 2. And you also have the slope rising or falling. So the rising slope is shown right here. So you notice the horizontal line or horizontal arrow. It's showing a rising slope. If I decide to, so this is a multi-purpose knob, and if I go down, I select falling slope. Notice what happens. So now I have a falling slope. I've selected falling. Notice what happens. So now it's showing a falling slope. I'll go back to the rising slope. Now it's showing a rising slope. So it doesn't really matter, whatever you like, you want to show a rising or a falling slope, that's really up to you. The mode auto is the one that I've chosen by default, and it just will force a trigger rather than a normal, which will not force a trigger. So there are some differences, and you can see in the manual for more details on the auto and normal. You also have coupling. So I have DC coupling here. And there's also another menu for the channel itself. So coupling here for DC, AC, or ground. So I'll show you what's the difference. The trigger has, it's a little bit different, the coupling. The channel also, the coupling is different. Here it's more, it will filter your signal. So let's say, for example, I put ground. So I have three choices, DC, AC, or ground. So let's suppose I select ground. So now it is ground. And so notice that the yellow line now is just a straight line. And the reason for that is because now I have grounded my signal. So I'm no longer measuring this signal, which is a 5 volt square wave. So I'm no longer measuring that. I'm just measuring ground. So the probe now is grounded. So that's why I'm showing a straight line, and this is just 0 volts. So I've grounded it. Now, if I can show AC if I like, and AC is fine because AC will just show the signal that I have. But it will filter out DC. So DC, on the other hand, will show everything, DC and AC signals. So so that's the first thing on the menu, and then below it you have the bandwidth. We'll keep the bandwidth as it is, 100 megahertz. That is the maximum, and you can see it right here. It's 100 megahertz. So anything beyond that will not be properly displayed on the screen. You also have the sampling here that shows 2 giga samples per second. And then below you have the voltage, what type of voltage division you want, coarse or fine. And then you have the probe attenuation, and the attenuation should be 10. That's the appropriate number for our probe. And then below it you have inversion, so you can invert your signal if you like. So notice what happens when so I'll just show you what it is. Invert, on, off. So I'll click on this button, it will turn it on, and look what happens to my signal. So it inverted my signal. So now I have it on. I'll turn it off, on again, off again, on again, off again. So notice that's, if you want to invert your signal, you can definitely invert it by using this button. So this is the on-off button. You can just click that, and it will remove the menu. So there are a few more things here that I would like to show you, and it is what you can also measure things. So there's a measure button right here. So if you click on it, and it'll tell you what you want to measure. So I have channel 1, channel 2, math, snapshot, and so on. But so I'll just click on channel 1, and if I want to just show, so notice here I have a drop-down menu, period, frequency, peak to peak, lots of things. But if I just want to, if I want the frequency, so I just go on frequency, highlight frequency with my knob here, and I select frequency, and then I can select maximum voltage, or peak to peak voltage, and that's it. And see, notice right away I have the peak to peak voltage 5.28, 5.36, fluctuates, and I have the frequency. And if I remove this, and if I take a look here, you also have a couple of important things here. 2 volts. So what does that mean, 2 volts? It means the vertical divisions is 2 volts. So if I go from this point to this point, it's 2 volts, and then another 2 volts, and then another 2 volts, and then another 2 volts. So 2, 4, so approximately here I'm at 5. but that is already measured by the oscilloscope itself. Now the horizontal divisions, I can ask the oscilloscope to measure the period. Okay, so what I have here is, so it's showing the period is, so we know that the period is the reciprocal of the frequency. So 1 over the period is equal to frequency, or 1 over the frequency is equal to the period. So the period here is 991.9 microseconds. So say from here to here, I have 992 microseconds. So which means that the so here it's showing you the division here, m us. So that means each, so from here to here, it's 500 microseconds. From here to here, it's 1,000 microseconds. So it's important to understand these things. So you get that from the bottom here. So as I said earlier, the division from here to here is 2 volts, and then you have another 2. So these divisions are 2 volts. But these divisions, these vertical ones, are 500 microseconds. There are a few other things. You notice that the trigger here, it's showing you at the top here that you already have triggered the signal. Okay, so at the top here it will tell you what's the state of the triggering. You can stop the trigger. So for example, so here it's showing green, so now it turns red. So the trigger has been stopped. Okay, the trigger has been stopped. So let's say, for example, I go back to channel, and then I ground it. So it's stopped. So it's not showing the ground because I've already stopped the triggering. Now if I go back and display DC again, it's not going to show anything. So let's suppose now I ground it and I press this. So now it's going to show me this line. But if I stop it, for example, and if I go back to DC, it's not going to show anything because I've already stopped the triggering. But if I press this, it's going to show me the triggering again. So I'm just going to bring this down here.